In 1951, two men attempted and succeeded in reaching the deepest known point on Earth, a place in the western Pacific Ocean known as the Marianas Trench, the deepest point of which is over 10 kilometers below the ocean's surface. They accomplished this feat in this vessel known as the exerted, a two-man submarine built to survive the pressure at those inhospitable depths. To give you an idea of what these men were up against, the pressure in this Marianas Trench is over 1,000 times higher than the pressure we experience at sea level. In a conventional submarine, the hollow tanks called ballast tanks are used in order to control depth. The exerted could not use them. Any hollow space would be crushed by the water pressure. How the engineers who built this machine to withstand these pressures without being crushed like a toothpaste tube is the question that will be answered at the end of this video. Fluid pressure behaves in a way very different from solid pressure. Consider this brick sitting on another brick. The top brick is being pulled down by gravity and exerts a force on the bottom brick. The force is equal to m times g, and the pressure can be found by dividing that force with the contact area between the bricks. The pressure is being exerted across the area and the normal to the plane of the area. But there is no pressure in the lateral directions, meaning no pressure sideways. The picture is very different in liquids. The pressure is being exerted from all directions. Look at this beaker filled with water. The toy gets pushed into water, displacing a volume of fluid equal to its own. This generates an upthrust which is pushing the toy back up. However, the toy is also experiencing a force all around it. This force is equal to the difference in the pressures experienced between the upper and lower points of the toy. In terms of density, acceleration due to gravity, and height below the surface of the liquid, the formula is given as P is equal to rho times G times H. Here we come across another interesting property of fluid pressure called the hydrostatic paradox. The pressure exerted by a fluid at any point in it is independent of the shape and volume of the fluid mass, but only depends on the height of the fluid. The principle of fluid pressure is used in a manometer. It is used in order to measure atmospheric pressure. A column of liquid mercury is held against vacuum by atmospheric pressure. Fluids also have another interesting property called Pascal's law, which states that a fluid exerts pressure equally in all directions. This principle is used in devices like hydraulic jacks, which are able to exert large forces based on this principle. So, coming back to the original question, how did they manage to submerge and come back? The exerted did not have hollow spaces for ballast. They filled this place with gasoline, as you can see here, which is incompressible and also less dense than water. The exerted also used electromagnets that held large amount of iron fillings that acted to make the submarine sink. You can see that here. When they had to ascend back to the surface, they simply let go of the ballast and come back. In the next lesson, we will learn about how fluids behave when they move. Let us summarize what we have learned.
Manorama Horizon. Learning made simple.